What's up, guys? So today we are going to learn some topics in discrete mathematics, and today I decided to make a video about it. So today what we are going to learn will be about, so let me just change the slide. So today we are going to learn about the topics which include introduction to set operations, union of sets, intersection of sets, and then lastly we are going to discuss what is meant by difference of different sets. So let's start from introduction of set operations. So introduction. So two or more sets can be combined in many different ways. There are a lot of ways through which we can combine two different sets, and we need and sometimes, and in fact a lot of times, we need to combine many sets in many different ways in order to get a certain result. So for instance, starting with the set of mathematics majors, so means mathematics majors means that the students who have taken mathematics subjects as their major at your school, and the set of computer science majors, so the students who have taken computer science subject as their major in the school. We can form the set of students who are mathematics majors or computer majors. The set of students who are joint majors in mathematics and computer science, the set of students not majoring in mathematics, and so on. So these are the examples. So there's a set. There's one set where the students are of the mathematics major, and there is another set where the students are computer science major. So we can do a lot of these things by combining these two different sets where we want different kinds of results. So for example, it's written here that for example, if we want to if you want the students who are if you want a set where that set contains the students who have majors in both the subjects, and the set of students who are joint majors means both subject in mathematics and computer science, the set of all the students not majoring in mathematics, and so on. So there are many results we can obtain by combining the sets in many different ways. So let's come to our first, you can say, the combination function. You can say that is the union of sets. So for example, let A and B be sets. For example, let A be the set of computer science majors, and B be the set of the mathematics majors. So the union of the sets A and B denoted by A union. So the union symbol in mathematics is denoted by capital U. So denoted by A union B is the set that contains those elements that are either in A or in B or in both. So when you are going to combine these sets and when you're going to do a union of them, so that set which will be obtained after the union will contain the elements that were either in A, that were either in the first set, or either in the second set, or in both. So if the elements are in the both set, that will be written only once, and if they are separate, means if they are either in A or either in B, they will be written in one set as well. So an element X belongs to the union of sets. For example, element X belongs to the union of sets A and B if and only if X belongs to A or X belongs to B, because it's not possible that if X does not belong to any of the sets and it's in the union of the two sets, it's not possible. So that is why X will always belong to either the first set or the second set if you're doing a union of two sets. This tells us that A union B equals X. So this right here is the set builder notation for the sets. So that says that A union B equals X such that X belongs to A. So, and this you can say the upside down caret symbol denotes the word OR. So X such that X belongs to A or X belongs to B. So here I have given an example. Set A is 1, 3, 5. Union set B is 1, 2, 3. And the union is going to be 1, 2, 3, 4, 5. So notice here that 1 is written here 2 times, and that is present in A and B. So what we are going to do is we are going to write it only once, and then the elements which are not which are exclusive, means which are either A and B, so we write them once as well. So that so here one is we write one once and we write three once, and then the rest is 1 2 3 5 is you get the union of the sets. Secondly, that is the intersection of the sets. So let A and B be two sets. Alright, the intersection of the sets A and B denoted by A intersection. So the intersection symbol is you can say capital N, but a little more round. So it's so you invert or you write the union symbol upside down, so that'll give you the intersection symbol. So denoted by A intersection B is a set containing those elements in both A and B. So means that the set that is going to be obtained after the intersection, that set will have the elements that the only condition is that the elements in that set will be present in both A and B, so not exclusively in any of the sets. So an element X belongs to, so let an element X belongs to the intersection of the sets. So X is the element that belongs to the intersection of the sets A and B if and only if X belongs to A and X belongs to B. So there's a difference between and or. In or, if the first condition is true, it doesn't matter whether the second condition is false or true, the result will always be true. But in and, if the first condition is true, the second condition will have to be true in order for the result to be true. If either of the condition is false, you'll get the false. You'll get false instead. So to A and X belongs to B. So this tells us that A intersection B equals X such that X belongs to A and X belongs to B. So X should always, has got to be present in both the sets. That is how you're going to obtain the intersection of the sets. So two sets are called disjoint, or you can two sets are called disjoint if their intersection is the empty set. So if the intersection, because empty set or null set is present, is the subset of every set and is present in every set. So there will be only empty set or null set which will be common, but not as, so you cannot consider empty set or the null as an element of the set. So that is why when there is no element common in the two sets, the intersection is going to be the empty set. Now our first set, as I've given here in the example, is 1 3 5 and intersection 1 2 3. So the number that is or the elements that are common, that are present in both the sets, is 1 and 3. So that is how we get the intersection. Now let's jump towards the difference of the sets. So difference in algebra and difference in sets is a little different. Let A and B be two sets. The difference of A and B denoted by A, and the symbol of difference is the same, that is the subtraction symbol minus, denoted by A minus B, is a set containing those elements that are in A but not in B. So the difference is going to be in the set terminology, the difference of two sets is going to be the set in which the elements of the set of the of the set which we obtain after the differentiation are going to be those elements that are in the first set, means that are in A but not in B. So the difference of A and B is also called the complement of B with respect to A. So generally a complement of a set means that you take its difference from the universal set, but here you're taking its difference from the set B. So the difference so the difference in this case can also be called the complement of B with respect to A. The difference of sets A and B is sometimes denoted by A by B. So the difference, another symbol for difference is, you can say, the slash. So the difference of sets A and B is sometimes denoted by A slash B. And element X belongs to difference means the difference, that the set we get after we do the difference of a and b. If and only if x belongs to a and x belongs to a and x does not belong to b. This tells us that a minus b, a difference b, equals x such that x belongs to b, x belongs to a and x does not belong to b. So here, as an example, the example I've given here is first set is 1 3 5 minus the second set is 1 2 3. So according to the rule of the difference of sets, we know that the answer of this, or the difference of this, is going to be the set which contains the elements that are not present in B but are present in A. So there is only single element, that is 5, that is in A and not present in B, because 1 3 is also present in B. The only element that is not present in B is 5, so the answer is 5. Alright guys, this was it for today's lecture. I'll see you guys tomorrow. Up till then, good luck, goodbye.